Hello guys. Today let's discuss about high level design of WhatsApp. A service like WhatsApp where you want to do, live, where we'll do real time chatting, right? Okay, so let's start with the functional requirement first. Very simple. It should be able to user should be able to do one-to-one chatting with each other on this. Then we will also cover that group creation and group chat is also available on this platform. Then we will have things like last seen, that if somebody has seen that or not. And obviously there will be things like in last scene, that if you want to block all those things or not, those kind of settings, but we can ignore those for this discussion. Then other than this, I think in basic functional requirement, I think these are good enough. It's just that these are real time chat, right? And everybody is able to see it as soon as you are sending the things, if another user is online. Then in terms of non-functional, first is very low latency, very low latency. Then we have or in other term, it is like real time chat, right? Second is have to be high availability. The system should not go down because so many users are using it. So you this should be up, no matter if even if one of your service or DB or some middleware is going down, even then system end to end should be able to serve. Other than this, basically this should be scalable. By scalable in the sense, you cannot make a design which will work for it is like you should be able to scale it further whenever you want to, because services like this, they grow exponentially. So maybe you are making for 100 million and suddenly you have to scale it for 1,000 million or billion. So I do not have the real numbers, but what I have heard is every day there are kind of 65 billion messages which are flowing via WhatsApp servers. So I think let's start with these basic requirements, and I'll not jump into the numbers, means what is the bandwidth and how much scale and everything, that math we can do later. Okay, so let me just design it, and we will discuss that design. So now we have our design. So I'm starting with a very basic design. So whenever we talk about real time data communication between, from your server to your client, or from your one client to other clients, there are options like you can do long polling, where your client is continuously checking with server whether they have anything for them or not, right? So long polling is kind of performance wise, it is not compared to WebSocket. So what I read so far is The best we have in these kind of scenarios, especially like real-time chat scenarios, the best solution we have is sockets, right? And if you have created or you have worked on any kind of socket programming, how this generally works is like your client try to open a socket connection with your server, and when you are doing it, so basically server will have a web socket dedicated for every customer, means every client whoever is interacting to them. And whenever server needs to communicate or send any kind of data to back to your client, they actually try to write that on that particular socket. So it is like if you have 50,000 clients connected to a server, that means you will somewhere you will maintain a list of those 50,000. So you will have some key, and then you will have those socket web socket objects stored against those keys. So this will be your object stored, this is your key, this is your object stored, right? And whenever you have to send, so you will simply do socket dot send, synchronous, asynchronous, that is different, but it's just that get this object and use the send method of this, and ultimately that data will be communicated back to that particular customer client in our case. So that is WebSocket. Now, how WhatsApp, something like WhatsApp will be created on WebSockets. So now think of basically you are having obviously multiple clients, and they can be mobile, they can be web, they can be desktop application and all, right? So different kind of clients. Ultimately we will have, because we are talking about this scale, then you will have you can say load balancer, and they can be load balancer of load balancer also. But to keep it simple, think of it as that you are having one primary, basically the main load balancer, which every client is hitting to. Then as soon as you will do basically your load balancer based on your location and availability of servers, they will connect you to one of the WebSocket handler server, right? Which means you are now live connected to that server. In terms of numbers, basically in normal servers, 60K live WebSocket servers can be there in one particular server. So we have to do that math, that if my users are like 100 million, then how many servers are required, and in which place how many servers are required, VMs and servers, right? So your user will be simply connected to one of the WebSocket server. Now when you are connected, you also need to store that information globally available for someone, globally available, so that when I am sending a message, and the other user whom I am sending a message, if I am connected to W1 WebSocket server, and my user, the other user whom I am sending, maybe he's connected to some W1000, right? Then how I will get to know that where this user is. So for that we have to store that info somewhere globally, so that we can fetch that info, that where is that particular user 2 is. And once we have that info, then this server can directly send to W1000 server, and that will communicate back to the user 2. So for that purpose, we will have something like a manager, which is, let's just call it a socket connection manager. Think of it at, this is a service where you are just having this kind of a list, that this user, where this user is, means not the socket object, because this you will save here itself in these WebSocket servers, right? But in socket connection manager, you will have things like, for user ID U1 is at W1000, U2 it as W2, for example, likewise. So this kind of info we will store in Redis, right? And we need obviously we need cluster, because the data is going to be big. There will be a billion 1 billion user may be there, so you cannot store it in one instance, so you will have a cluster of Redis. This service have to be fast because you will query it very frequently. So that is why we are not going with a database. We are going with a cache, because cache will serve faster comparatively. So this is a very simple service where you are just going to query like, give me the information of where user 1 is or where user 2 is, right? It will return you the list of that. It will return you the info of that user. That user 1 is at this particular machine. Then we also need a component like a chat service. What does that mean? In application like WhatsApp, we are not storing our entire chat into the backend, right? It is like all your chat, your entire data is in your device, your mobile, right? And they are just using the infra to transfer that message from your device to the receiver, right? But it is like, when they could basically they are trying to do it live, but maybe the user too is not available online, right? In those scenarios, they have to store it somewhere for the time being, so that it when user comes online, they should be able to deliver it from this. So for that purpose, we need something like a chat service. So chat service is nothing where it is like, we will query things like, for this user, give me all the messages which are not delivered or not seen yet, right? So for that, to store those messages, we are storing a service like, we are using a database like Cassandra, because like I said in starting, there are huge number of messages which are flowing in a day via WhatsApp, right? So to store that kind of data, and you are going to query from that data. Your Cassandra performs very well in those scenarios where you have ever growing data, like data is growing continuously, right? Like every second you are getting newer data. It is not like you are updating same entities, you are adding entities every passing by tick. But if you see, your queries are very simple. Your queries are like, for given ID, user ID, give me messages which are after this time, because I have read everything before that time, something like that. Your query pattern can be like, give me messages for user 1 where their properties last seen is false, right? Something like that. Or give me messages for user 1 where created time is greater than X, because client is saying that before X I have every data which got created before X, right? Things like that. So that is where Cassandra performs very well, where your queries are simple but your data is very big, right? So this is a kind of columnar DB. I'll make a separate video about this DB, or how to choose databases. So I'll make that video. But yeah, this is one of the, I would say, the best DB which can perform in this kind of scenario. Now I think these are the components overall which we need to build a WhatsApp for one-to-one chat scenario, right? If we see how our one flow will be, for example, let's suppose this user, let's call it user 1, wants to send a message to a user 2, right? So what it will do is, it will send this info to server, or to this WebSocket, wherever this guy is connected to, that I want to send a data to you too. Now maybe this guy is, because obviously for WebSocket handler also we will have a cache, because very frequently when people are communicating, they are sending messages to same guy, right? So WebSocket handler might already be knowing that where user 2 is to which WebSocket server that user 2 is connected to. For that, they will basically, we will have a separate Redis supported for this guy, where it will store the data. It will check, do I have the info of user 2, right? If it is having that info, and this can be an in-memory Redis also, we don't need to have a external this thing. So if it is having the info, it will directly communicate to that server that I'm having a message for user 2 and deliver it. If not, then it will go to a usual path where it will, via load balancer, it will connect to socket manager and ask for where u2 is. Now in first scenario, maybe u2 is connected to some, like I said, w1000 server. So it will return back the info that u2 is connected to w1000, and once it is once my w1 is having that info, it will send that, basically it will hit a request to w1000 that here is a message for user 2 and send the message. Then my w1000 will deliver that message to user 2. In parallel, it will also basically hit my chat service to store that message, right, into Cassandra, that this is the message and I already communicated to WebSocket, means whatever the state is, that will happen. This is one scenario where both the users are live, right? They are actually connected to one of the WebSocket server. Another scenario can be when user 1 sending the info to user 3, right? It will connect to WebSocket that deliver this message to user 3. Now user 3 information WebSocket server is not having. It will ask your socket manager, connection manager. Then connection manager will also return like, I do not have info. That means user 3 may be offline, he is not connected. So it will simply dump that data into chat service and done. So status of that message will be delivered, sent, basically sent to the server, but not delivered to the customer. In this scenario, whenever user 2 will come online, user 2 will first thing, it will open a connection with any of the WebSocket server. In parallel, it will basically hit chat service, do I have any message, unread message for me? Then chat service will return, and basically it will be sent to the user as a normal get request. When you will do that, at the same time you have to update user 1 also that this message is now delivered, right? So we see those one tick, double tick, then blue tick, right? All those things. In that scenario, what will happen is, if user comes online and maybe he haven't seen it, but he just come online, so he pulled all the messages, so those messages are delivered now. So whenever you are responding back, what you will do is, from your chat service we can have basically a pub sub model. So think of a Kafka cluster, right? Think of a Kafka here, where you are just sending the asynchronous a task that these messages got delivered, basically pulled by the user. In that scenario, we will basically via Kafka asynchronously we will communicate it to user 1 if user 1 is connected. So it is like another service here, right? Let's call it last seen service, is responsible for delivering this data to user 1. So this again, if user is connected, we will deliver via this channel. If not, then whenever user will come online, we will basically the user will receive that info from last seen info, that yes, this user have seen all these messages and all. So this is about one-to-one. Now to enable group chat functionality into the same, let's jump into that. Let me just change the same design and think of it. Okay, I cleared that out, and it is same design what we had earlier. Now to add functionality like group chat, we need two more services, according to me. One is obviously we need group info, who all are there in this group, you know. So for this is very relational. For that, I'm storing it in simple SQL DB, where you will have things like for G1, your group one, basically these are my users. So users, and basically there is, you can say, many to many relation between your user and your group. That info is here, right? And to deliver that info, we will create a thing like group service, where you are querying, okay, give me the info of give me all the user IDs or user infos of that particular group. So you will query like, for G1, give me group list of users, right? And all other group things, maybe icon and blah blah blah. Then we also need something like group message handler. What it will do is, now think of let's just discuss a end-to-end flow, similar thing where user one is sending a message into a group one, right? It will connect to the WebSocket. Now WebSocket in cache, we might store that, you know, for group one, this is my user list, and send the messages to all the users. In normal scenario, when this WebSocket is not having that data into you know, the in-memory Redis cache, what it will do is it will query your group message handler that send this message to this group G1. What this guy will do is, first it will get the list of all the users, right? Once it is having list of all the users, then our flow will be same as what we had for one-to-one. So it is like, let's suppose you got U2, U4, U6, U27. Let's suppose you have these things. So this guy will simply get the info of you know, from your socket manager service. It will get the info of all these users, where these guys are, and then this guy will pump that to WebSocket services, that wherever these guys are connected to, that delivered this message to those particular users. And that is how we will be able to basically deliver group messages also with the same setup. So I think yes, we can enable that. So this is a very simple basic you know, the design which is scalable, because if you see all the components which we used everywhere, be it your WebSocket handler, be it your manager, chat service, and all the services and DBs, they are scalable. You can basically at any given point you can add you know, you can increase the number of services. So because they are not tightly coupled, they are separate, you will be able to scale any component whichever is having, you know, more queries. You can scale them easily. In addition to this, obviously you will have things like analytics you want, and maybe you have to have you know, raw all the events to do you know, different kind of data viewing. For those, think of like you are pumping all the events from multiple services into your Kafka, and then behind Kafka you will add multiple things. Like one is like your analytics will be served from here. Then you can have think of, you can have your something like a big data here, right? Your Hadoop or something is setting where you are pumping the entire data, and on that big data you can do further things, you know, have visualize it on Power BI, or you know, different things, whatever you want to do, run some machine learning algorithms on that data and all, map reduce, whatever you want to do, you will do on that. So those things you can aid easily. If you will pump all the events, then you can use those raw event to do different kind of queries. So yes, I think that's it about this design, and this is a very simple clean design for simple and clean design for a message service like WhatsApp. So yeah, thank you guys. Have a nice day. Bye.